We live in a universe of unimaginable beauty, glittering stars, radiant nebulae, and tranquil blue worlds like our Earth. But beyond this familiar poetry lies a much darker truth. The cosmos is not just a gallery of wonders, it is also a theatre of nightmares. Imagine a planet so black it swallows light whole, glowing faintly like a dying ember against the abyss. Or a world made almost entirely of carbon, where diamonds larger than mountains may lie buried beneath oceans of fire. Picture rainstorms of molten glass, falling sideways at bullet speed, driven by winds faster than anything our world has ever known. These are not myths. They are real places, alien worlds orbiting distant stars. Planets that defy the very definition of what a planet should be. They are extremes of nature, so hostile, so bizarre, that they stretch the limits of human imagination. Tonight we venture into the abyss. We'll uncover the darkest planet ever found, a giant's hollow heart, a diamond inferno, and worlds where death reigns from the sky. Each of them hides a secret, a clue to the deeper mysteries of the universe. This is the story of dark worlds' hidden secrets, the mysterious planets of the cosmos. Imagine drifting through the constellation of Draco, a place once feared in ancient myths as the home of monsters. Through a telescope, you catch sight of an ordinary star, one among billions, faintly glowing in the black sea of the universe. But then, something strange happens. The light begins to flicker. It dims with a steady rhythm, as though the star has a heartbeat. Astronomers lean closer, studying the data, and realize something colossal is passing in front of it. That hidden world would later be named strangest 2b, and it would reveal itself as one of the darkest planets ever discovered. The year was 2006, when the Transatlantic Exoplanet Survey was scanning for new worlds. Their mission was simple: watch thousands of stars and measure the faint dips in light caused when a planet passes across its sun, a method called the transit technique. At first, strangest 2b seemed like just another hot Jupiter, a giant gas planet orbiting extremely close to its star. But when its light signature was analyzed, the results shocked the scientific community. Unlike other planets that reflect a portion of starlight, Jupiter reflects about a third and Venus nearly 3/4. strangest 2b reflected almost nothing. Less than 1% of light bounced back. This wasn't merely dim, this was blacker than coal, darker than the paint used to absorb light in telescopes. It was as if the planet itself were devouring every photon that touched it. Astronomers described it as a phantom, a world so dark that it should have been invisible, a cosmic shadow orbiting a flame. The only reason we know it exists is because of the way it blocked its star's light, not because it gave any light back. Standing there, if anyone ever could, would feel like standing in a void. No gleam, no glow, no horizon, just an oppressive blanket of black pressing in from every direction. What makes it so black is still debated. Its atmosphere contains chemicals like sodium and potassium vapors that absorb starlight instead of scattering it. Other exotic compounds, possibly titanium oxide, may also contribute to its strange chemistry. Unlike Jupiter, which is wrapped in bright reflective clouds, strangest 2b has no protective veil. It is stripped bare, its atmosphere working more like a sponge for light than a mirror, and yet it is not entirely invisible. At over 1800 degrees Fahrenheit, the planet burns with its own faint radiation. Seen from space, it doesn't shine, but rather smolders, a deep red glow, like the dying ember of a fire lost in the void. Adding to its strangeness, strangest 2b is tidally locked. One side always faces its star in endless daylight, scorched by eternal fire, while the other side remains trapped in an infinite night. The division between them is a twilight frontier, a razor-thin band where unimaginable winds howl, transferring heat from day to night at thousands of miles per hour. To stand at that border, if such a thing were possible, would mean facing two worlds at once, a sky of unbroken fire on one side and an abyss of absolute black on the other, while storms of vaporized metals tore across the horizon. The unanswered question is why it is darker than theory ever predicted. Scientists expected it to reflect little light, but not this little. Some suspect that exotic clouds, made not of water or methane but of molten metal vapors, may trap the starlight completely. Others wonder if it is simply a planet in collapse, its atmosphere breaking apart under the weight of its own star's radiation, leaving behind nothing but that ember-like glow. It might seem like a curiosity, just another extreme in a universe full of extremes, but strangest 2b is more than a scientific oddity. It is a crack in the model of planetary science. Worlds are supposed to behave in predictable ways, galaxies. They orbit, they shine, they reflect, they scatter. Strangest 2b refuses. It tells us that the diversity of planets is far beyond what we imagined. If a world can exist that eats light, what else might be out there, hidden in the shadows? Strangest 2b is more than a planet. It is a warning, a reminder that the cosmos is not built for our comfort or our understanding. From 750 light-years away, in the ancient constellation of the Dragon, it drifts invisibly, a coal-black giant lurking in silence. It doesn't dazzle like Venus. It doesn't charm like Jupiter. It waits, a void wrapped in fire, an ember of a world that refuses to shine, the darkest planet we know, the planet that devours the light. Far away in the constellation of Centaurus, astronomers once detected a world that seemed, at first, unremarkable. Its size was close to Neptune's, its orbit blisteringly close to its star, circling every 18 hours. But when scientists measured its mass, something didn't add up. This planet was far heavier than it had any right to be. It wasn't a bloated gas giant like so many hot Jupiters already discovered. It was dense, compact, strangely stripped down. Slowly, a haunting picture began to form. What they were seeing was not just another planet, but the exposed heart of a giant that had been destroyed. This world is called TOI 849b, and it is a cosmic corpse. Imagine Jupiter without its majestic atmosphere. Imagine all its clouds, its storms, its colourful layers, peeled away like skin until only the raw, rocky core remains. That is TOI 849b, the skeletal remains of a gas giant, a planetary autopsy preserved in the vacuum of space. When the transiting Exoplanet Survey Satellite, or TESS, first spotted it, astronomers were puzzled. It was too massive to be a regular rocky planet, yet far too dense to be a gas world. At 40 Earth masses, it was heavier than Neptune, but packed into a much tighter space. The only explanation, it was the naked core of a gas giant whose atmosphere had been ripped away. What could cause such violence? Perhaps a catastrophic collision in its early life, another massive planet slamming into it and blasting away its layers, or perhaps its star itself, orbiting so close that gravity and radiation peeled it piece by piece, stripping it until nothing was left but the skeletal remains of what once was a world like Jupiter. To picture TOI 849b is to imagine devastation frozen in time. This is not a place of gentle skies or soft clouds. Its surface, if it can even be called that, is likely a hellscape of molten rock and searing gases, baked under temperatures surpassing 1500 degrees Celsius. It circles its star so tightly that a year there lasts less than a single day on Earth. Each orbit is a cruel embrace, each pass bringing more torment as the star's energy blasts what little remains of its atmosphere into space. But the eeriest part of TOI 849b is not just its violence, it is what it represents. For the first time, humanity could glimpse the inside of a gas giant. Our own Jupiter and Saturn hide their cores beneath tens of thousands of kilometers of clouds. We theorize, we model, but we cannot see. TOI 849b gives us a stripped-down version, a laboratory in the sky where the secrets of planetary hearts are exposed. It is a scar in the cosmos that teaches us how giants are born, how they evolve, and how they die. Think about that for a moment. This planet once might have been as majestic as Jupiter, with swirling storms, giant rings of moons, and a commanding presence in its system. Now, it is nothing but the ghost of its former self, its atmosphere gone, its beauty shredded. All that remains is a hot, naked stone wrapped too tightly around its star. In a way, it's like staring at a planetary skeleton, bones bared to the cosmic night. If you were to stand on TOI 849b, though no human ever could, you'd find no skies above you, no horizon coloured by clouds. Instead, you'd see a blazing star dominating half the heavens, filling the sky with fire, while the ground beneath your feet cracked and glowed with impossible heat. Every breath would be poison. Every step would be on a surface, forged in violence. You wouldn't be visiting a living world, but rather the grave of a world, a monument to destruction. And yet, in its silence, TOI 849b speaks volumes. It tells us that planets are fragile, that even giants can fall. It reminds us that creation and destruction in the cosmos are not separate. They are two halves of the same process. A world is born, it thrives, and it dies. Sometimes its death is quiet, like Mars, its atmosphere leaking away over billions of years. But sometimes its death is violent, spectacular, and final, as if the universe itself is tearing off the mask to show us what lies beneath. For scientists, TOI 849b is a gift wrapped in tragedy. It allows them to peer into a planetary core, to understand what lies under the stormy tops of the giants in our own system. Its density, its composition, its orbit, all reveal secrets that no other planet has offered. This is not just a corpse, it is a book, open to those who can read it, written in the language of mass and gravity, pressure and heat. And yet beyond the science, TOI 849b is also a haunting vision. It is devoured. That happens when a planet loses everything that made it beautiful. It is the reminder that the cosmos does not care for stability, for permanence, for safety. It is a reminder that nothing, not even the mightiest giants, are safe from destruction. When astronomers look at TOI 849b, they do not just see a planet, they see a scar. They see what remains when the chaos of the universe wins. They see a core stripped bare, a heart still beating after its body has been torn apart. If TRES 2b is a phantom that eats light, then TOI 849b is a corpse, the broken skeleton of a fallen titan drifting forever in silence around its star. 40 light-years away in the constellation Cancer, there is a planet that defies imagination. From afar it looks small, rocky and unassuming, but up close it is one of the most extreme places ever discovered. Astronomers call it 55 Cancri E, though others have given it darker names. The Diamond Planet, the Lava World, the Burning Jewel. Twice the size of Earth and 8 times its mass, it is a super-Earth, familiar in scale but utterly alien in every other way. Its orbit is suffocatingly close to its star, so close that a year there lasts only 18 hours. Picture a world racing endlessly around its sun, tethered to fire, locked in a cycle that never slows. On the surface, temperatures rise to over 2,000 degrees Celsius, hot enough to melt steel, hot enough to vaporize rock, and because the planet is tidally locked, one hemisphere is always bathed in brutal daylight, while the other is trapped in permanent night. On one side, oceans of lava may roll endlessly under skies painted with fire, while the far side is cloaked in eternal shadow and silence. Scientists once speculated that this strange planet could be made largely of carbon, compressed under extreme pressure into crystalline diamond. Imagine standing on ground that gleams faintly beneath the lava, entire mountains of diamond buried beneath the crust, more wealth than humanity has ever dreamed of, locked away in a world that would burn you alive the instant you set foot there. The idea of a diamond planet is poetic, almost mythical, yet it may be true. If carbon dominates its composition as models suggest, 55 Cancri E could be the single richest planet in the galaxy, but utterly unreachable, a fortune that mocks us from afar, forever untouchable. And even if it were diamonds, this is no paradise. This is a hell forged of fire and pressure. If you could look across its horizon, you would see lava, lakes glowing like open wounds in the crust, plumes of volcanic fire spewing into an atmosphere made of exotic gases. That atmosphere itself is unstable. At times, telescopes detect hints of volatile gases swirling, and then weeks later they vanish, as though storms are stripping the skies away and rebuilding them again. Some astronomers suggest the entire atmosphere may collapse and rebuild depending on volcanic activity, a world breathing in fire, exhaling death. The heat is relentless. On Earth, lava flows cool and harden into black rock, but on 55 Cancri E, the heat from the star is so intense that oceans of molten rock never solidify. They bubble and churn endlessly, waves of fire breaking against coasts that are themselves burning. The very surface of the planet may be reshaped constantly, continents melting, seas of magma rising and falling in an eternal cycle of destruction. To walk there would be impossible. Your body would not even burn. It would simply vaporize, torn apart by temperatures so high that molecules could not remain intact. Any spacecraft attempting to orbit close would be scoured by radiation and torn by gravitational forces. Even the night side, shielded from the star's direct heat, is no safe haven. Heat from the day side bleeds across, carried by supersonic winds that may scream across the planet, turning the atmosphere into a global furnace. And yet in its violence, 55 Cancri E tells us something profound. Planets are not uniform, not gentle spheres orbiting their stars like clockwork. They can be monsters, forged in fire, reshaped by forces we can barely comprehend. They can be diamonds wrapped in lava, jewels that mock the very idea of beauty, showing us that the cosmos values extremes over balance. The story of 55 Cancri E is not just about wealth or fire. It is about what lies possible in the diversity of worlds. For centuries, humans imagined planets as versions of Earth, maybe warmer or colder, maybe bigger or smaller, but still cousins of our own. Worlds like 55 Cancri shatter that illusion. Here is a planet so close to its star that it is more furnace than world, a place where geology and atmosphere are locked in a war without end. It is proof that nature creates not only places where life might thrive, but also places where life itself seems to be mocked. Worlds designed to kill, not to cradle. And still, we are drawn to it. The idea of a diamond planet lingers in our imagination, a world where mountains gleam in crystal, where valleys sparkle in riches beyond measure. But the truth is cruel. If diamonds exist there, they are buried beneath oceans of lava, hidden beneath pressure that would crush steel, in a world that destroys everything that dares approach. It is as though the universe created a treasure chest, filled it with wealth, then set it ablaze and locked it forever. When astronomers gaze at 55 Cancri E, they do not just see another rocky planet. They see possibility. The possibility that planets can be stranger than our myths, harsher than our nightmares, richer than our fantasies. They see a world that is both beautiful and horrifying, a paradox made real. And in that paradox lies the deeper truth. The cosmos is not designed for us. It does not create worlds to match our expectations. It creates whatever physics allows, whatever chemistry shapes, whatever extremes emerge. And sometimes those extremes take the form of a world like 55 Cancri E, burning endlessly under the light of its star, a diamond inferno that will never cool. It is perhaps the cruelest kind of beauty, not the beauty of life or balance, but the beauty of fire and destruction. It is a reminder that even in the endless darkness of space, creation can take forms we struggle to understand. Some worlds shine, some worlds nurture, and some, like 55 Cancri E, blaze with a brilliance that is both terrifying and irresistible, forever reminding us of the thin line between wonder and nightmare. There are some planets that live fast and die young, their very existence a countdown to annihilation. One such world drifts in the constellation Auriga, over 1,400 light-years away. From afar, it looks like just another gas giant circling its star. But look closer and you see a planet in the process of death, a world being slowly devoured by the very star it orbits. Astronomers call it WASP-12b, though it might better be described as a cosmic tragedy unfolding in silence. When scientists first discovered it in 2008, they noticed something unusual about its orbit. The planet raced around its star in just over a single Earth day, closer than Mercury is to our own sun. That closeness comes with a terrible price. The gravity of the star stretches the planet into an elongated, egg-like shape, tugging at it with such force that the outer layers of WASP-12b are being pulled away, stripped into space. Each orbit, each moment, the planet loses more of itself, feeding its star in a slow and merciless consumption. If you could stand above it, you would see a gas giant swollen and distorted, its atmosphere spilling outward in streams of glowing material like smoke pouring from a fire. Around it, a faint ring of gas lingers, not a majestic Saturn-like ring, but a death shroud, a halo of its own body torn away. The star drinks from this stream constantly, siphoning life until nothing will remain. Astronomers estimate that in just 10 million years, a blink in cosmic time, WASP-12b will be completely destroyed. The planet's temperature is as brutal as its fate. Surface conditions reach nearly 2,500 degrees Celsius, hot enough to melt most metals. Clouds, if they exist, would be composed not of water but of vaporized metals and exotic chemicals. The skies glow with radiation. The horizon bends under the pressure of gravity. This is a place where nothing can survive. A world whose destiny is written not in centuries or eons, but in its very orbit. And yet, as terrifying as it is, WASP-12b has become a rare opportunity for astronomers. Watching a planet die in real time is almost unheard of. Planets live for billions of years. Their deaths, when they happen, usually leave only remnants, scars, or distant echoes. But here, with WASP-12b, we are witnessing the process itself. It is as though nature has torn open the curtains to let us glimpse what happens when a planet strays too close to its star. The sight is haunting. Imagine a giant, once proud and complete, now stretched, bleeding atmosphere into space, powerless to escape its star's grip. It does not explode in drama. It does not shatter in violence. Instead, it is consumed slowly, piece by piece, until there will be nothing left but memory. Silent, inevitable, beautiful in a terrible way. The science behind its death is simple but merciless. The planet orbits so close that tidal forces, the same forces that cause our ocean tides here on Earth, are magnified 1,000-fold. These forces stretch the planet, weaken its grip on its atmosphere, and create pathways for gas to leak away. At the same time, the immense radiation from the star heats the atmosphere until it boils off. Together, gravity and heat form a trap from which no world can escape. If you were close enough to see it with your eyes, the image would stay with you forever. A swollen giant glowing orange with heat, streams of gas arcing toward its star like bridge, airs of fire, a sun bloated with its stolen feast, burning brighter as it consumes its victim, the void around them lit faintly by the haze of planetary remains. It is cosmic cannibalism, and it is happening not in myth, not in theory, but in real time, in the silence of deep space. But even in its doom, WASP-12b teaches us. It shows us how fragile the balance of planetary systems can be. A slight change in orbit, a migration too close to a star, and a giant can be destroyed. It also warns us of the long fate of worlds. Billions of years from now, when our own sun swells into a red giant, it too will devour Mercury, Venus, and perhaps even Earth. What we see in WASP-12b today is not just an alien tragedy, it is a mirror of our own distant future. Some scientists even believe that WASP-12b's destruction may alter its star. The gas pouring into the sun could change its chemical makeup, leaving traces of the planet behind long after the world itself is gone. In this way, WASP-12b will not only die, but will become part of the star itself, its memory imprinted forever in the light that reaches across the cosmos. It is easy to think of planets as eternal. They are massive, immovable, ancient. But WASP-12b reminds us that nothing is eternal, not even giants. Everything is vulnerable to time, to gravity, to heat, to the merciless rules of physics. Its story is one of inevitability, a slow-motion collapse written in the laws of the universe. And so WASP-12b continues its final orbits, circling its star like a moth trapped in flame, each pass tearing more of itself away. There will be no rescue, no second chance, no miracle, only consumption, only silence, only the certainty that someday soon the giant will vanish, and all that will remain is a star burning brighter, carrying in its light the memory of the world it destroyed. If TRES-2b is the planet that eats light, and TOI-849b is the corpse of a fallen giant, then WASP-12b is a victim, a planet doomed not by accident, not by collision, but by the simple fact that it strayed too close. It is a cosmic reminder that proximity can be fatal, that beauty and destruction are sometimes the same thing, and that in the end, even the mightiest worlds can be devoured. Not every nightmare world glows with lava or collapses under the pull of its star. Some kill in ways more subtle, more terrifying, by turning their skies into weapons. 64 light-years from Earth, circling a star in the constellation Vulpecula, lies a world that looks deceptively beautiful. From a telescope's eye, it shines with a deep azure hue, almost identical to Earth's oceans. But this blue is not the color of water, it is the color of death. This is HD 1897333b, a planet where storms rage with such violence that they turn the skies into a rain of glass. At first glance, HD 1897333b seems like a typical hot Jupiter, a gas giant orbiting close to its star, discovered in 2005 using the familiar transit method. But as astronomers studied its light more closely, they realized the atmosphere contained silicate particles, tiny bits of glass. The winds on this planet don't just blow gently across its skies. They scream at over 5,400 miles per hour, more than 7 times the speed of sound. In such a storm, those silicate particles are lifted and hurled sideways, transformed into a horizontal rain of molten shards. Imagine standing in a hurricane where every drop of rain is a blade of glass moving faster than a rifle bullet. That is the weather of HD 1897333b. From space, its blue hue is dazzling. It could fool you into thinking it is an ocean world, Earth's twin, painted in sapphire light, but that beauty is a lie. The blue comes from the way the silicate particles scatter light. Not from oceans or skies. Up close, this is not paradise, it is apocalypse. The entire planet is wrapped in storms that never stop. Winds so fast they could tear apart entire cities in seconds, shredding everything in their path. The conditions are so extreme that even spacecraft could never survive. Any probe descending into the atmosphere would be torn to ribbons, its metal skin shredded by the storm of glass, its instruments burned by the heat. The winds alone would smash it into pieces, scattering its remains across a sky that never calms. Even orbiting nearby would be perilous, as the radiation from the star and the sheer fury of the planet's storms would disrupt signals, destroy electronics, and make observation a battle against the void. But the horror of HD 189733b is not just in its storms. It is in the realization that nature can weaponize something as simple as rain. On Earth, storms give life. They water crops, they fill rivers, they renew the soil. On this planet, storms are instruments of death, shredding anything that dares to exist in their path. What we consider nurturing here becomes lethal there. It is the same physics, the same concept of rain and wind, twisted by alien conditions into something unimaginable. If you could stand in the upper atmosphere and look across the horizon, the view would be terrifying and beautiful all at once. Lightning would crackle across the skies, illuminating clouds of glittering shards, each flash revealing a world in chaos. Winds would scream, pulling you sideways with impossible force. The raindrops, particles of glass, would slice through everything, embedding themselves in whatever unlucky surface they struck. The sound would not be like thunder or storm. It would be the shriek of a billion knives in the air. And yet there is a strange beauty in the violence. Scientists describe the scattering of blue light as breathtaking, a jewel-like radiance glowing against the black of space. From far away, HD 189733b is one of the most photogenic exoplanets we have ever seen, a sapphire drifting in the dark. Its deceptive calm reminds us that not all beauty is safe, and not all dazzling colors are born of peace. Some are born of terror. For astronomers, the discovery of silicate rain was more than a shocking headline. It was a breakthrough in understanding just how diverse atmospheres can be. Earth's clouds are made of water vapor, Jupiter's and Saturn's are ammonia and methane. But here we see clouds of glass, storms of molten particles. It pushes the boundaries of what we expect, forcing scientists to reconsider the possibilities of what skies and weather can look like across the universe. If this is possible, then what else is possible? Could there be worlds with clouds of iron, planets where the rain is molten lead? Each discovery, like HD 189733, opens the imagination to new nightmares. The more we study, the clearer it becomes that this planet is locked in a cycle of fury. Orbiting extremely close to its star, its atmosphere is constantly heated and stirred, ensuring the storms never end. There is no calm season, no safe haven, no break in the chaos. For billions of years, it has raged this way, and for billions more, it likely will continue, a perpetual storm world doomed to an eternity of violence. But perhaps the most haunting thought is this. When we look at HD 189733b, we are not seeing a static image. We are seeing a living, changing world, one where the very idea of weather becomes alien. We are watching nature reinvent something familiar, rain, wind, storms, into something monstrous. It is the uncanny made real, the recognizable twisted into horror. That is what makes this planet so unforgettable. Astronomers often talk about habitability, about finding Earth-like planets where life might take hold. But worlds like HD 189733b remind us of the opposite truth, that most of the cosmos is not built for life. It is built for extremes, for experiments in physics, for conditions that border on the impossible. Life is the exception. Death, violence, and chaos are the rule. And so HD 189733b continues to circle its star, a sapphire jewel glittering in the darkness, deceiving the eye with its beauty while hiding storms of glass and winds of death. It is a reminder that the universe is not designed for us. It does not care for comfort, for safety, for life. It creates what physics allows, what chemistry dictates, no matter how terrifying the result. From far away, it is beautiful. Up close, it is hell. And in that contradiction lies its mystery and its power. Not all hellish worlds are giants. Some are small, rocky, and deceptively familiar until you get close enough to see what they really are. In 2011, astronomers studying the data from NASA's Kepler Space Telescope discovered one such nightmare. At first, it seemed like a triumph, the first rocky exoplanet confirmed by Kepler, proof that Earth-sized worlds existed beyond our solar system. But as the details emerged, excitement gave way to horror. This planet, known as Kepler 10b, was no Earth. It was a world drowned in oceans of lava, a furnace of rock and fire orbiting so close to its star that the very concept of a solid surface becomes questionable. Kepler 10b orbits its star at a distance 20 times closer than Mercury is to our Sun. A year there lasts less than a single Earth day, 20 hours from sunrise to sunrise. The star's radiation pounds it with relentless energy, heating the surface to temperatures around 2500 degrees Celsius, hot enough to melt iron. This isn't just heat that scorches, it is heat that liquefies worlds. Imagine an Earth where the continents themselves are seas of glowing red magma, flowing endlessly, never cooling, never hardening. That is Kepler 10b. Standing on its surface, if such a thing is possible, would be like standing on the rim of a furnace that never ends. The ground beneath your feet would shift and bubble, molten rivers racing across the horizon. Volcanoes would erupt not as singular events, but as a constant state of being. The air, if any remains, would shimmer with vaporized rock and metal, dense clouds of mineral dust rising and falling in waves of fiery ash. Every breath would be poison, every step would be into fire. This is not a planet where life could even dream of existing. It is a world defined entirely by destruction. The tidal forces on Kepler 10b are immense. Orbiting so close to its star, it is locked into a permanent day and night, with one side forever blasted by sunlight and the other forever in darkness. On the day side, lava oceans roll endlessly under skies of fire, their waves cresting and breaking in molten arcs. On the night side, temperatures plummet, perhaps freezing some of that molten rock into a fragile crust, only to be shattered again as the planet's rotation and winds drag the molten seas back into the light. It is a cycle of fire and freezing, a world split in half between burning and breaking. To call this a planet is almost misleading. It is more like a fragment of a world caught in an impossible orbit, a remnant that has become something new and terrifying. Scientists believe Kepler 10b might once have been much larger, perhaps even a gas giant. Over time, its star's radiation stripped it of its atmosphere, boiling away everything soft, leaving behind only the rocky core. What we see today may be the skeleton of a planet, cooked down to its essence, forced into an existence of endless fire. And yet, it tells us something important. For centuries, humanity dreamed of other Earths. We imagined planets with oceans and skies, forests and clouds, places where life could thrive. Kepler 10b shattered those dreams with brutal clarity. It showed us that rocky worlds exist in abundance, but they are not always havens. They can be hells, molten and merciless. Reminders that Earth is rare not because it is a planet, but because it is a planet that sustains life. Kepler 10b is Earth turned inside out, a mirror of what our world might have been had we orbited just a little closer to the Sun. The very existence of lava worlds like Kepler 10b expands the boundaries of what we know. They force scientists to imagine geologies we never considered, to simulate atmospheres made not of water vapor or nitrogen, but of rock vapor and molten metals. They challenge our ideas of planetary evolution, showing that stars and their planets are locked in violent dances that can strip, reshape, and destroy worlds. What we once thought of as impossible is, in fact, commonplace. And with each new telescope, each new discovery, we are reminded that the universe thrives on extremes. Still, there is a strange beauty in Kepler 10b's terror. Imagine looking at it from space. A small world glowing faintly like a coal, its day side shining with rivers of molten fire, its night side hidden in shadow. It would look alive, as though the planet itself were breathing, molten oceans pulsing like blood through veins of stone. Terrifying, yes, but also mesmerizing, a vision of raw planetary power. If Trieste-2b is darkness, if TOI-849b is a corpse, if 55 Cancri E is a diamond inferno, and if WASP-12b is a victim being devoured, then Kepler 10b is pure hell, a crucible of fire where stone and star are locked in eternal embrace. It is a reminder that not all nightmares in space are giants. Some are small, some are rocky, some are just like Earth in size and shape, but twisted into horrors beyond imagining. And so Kepler 10b circles endlessly, trapped in a 20-hour year, its surface boiling, its rocks vaporizing, its oceans glowing red. It will never cool, never calm, never know silence. It is a planet condemned to burn, not for a day or a century, but for eternity. A planet that proves once again that the universe is not only stranger than we think, it is stranger than we can think. We have traveled across the strangest corners of the cosmos. We've seen a world that swallows light until it glows only faintly like an ember in the void. We've seen the corpse of a giant, its skin stripped away, leaving only a broken core. We've stood at the edge of a diamond inferno where wealth beyond imagination lies buried beneath oceans of fire. We've watched a planet devoured slowly, its body pulled apart by the star it cannot escape. We've looked into skies that rain molten glass, driven by winds faster than sound. We've walked across a world of lava oceans, a crucible of stone and flame. Each one of these planets seems like something born from nightmare, a story invented to scare children. And yet, they are all real. They exist, they orbit their stars right now, living testaments to how extreme and unforgiving the universe truly is. What do these worlds tell us? That planets are not uniform, that they are not all safe havens waiting for life. They are products of physics pushed to extremes. Some are born too close to their stars and become furnaces. Some grow too large, only to be stripped down until they are nothing but cores. Some are locked in tidal embraces that create eternal days and nights, boiling one side while freezing the other. Some become so saturated with exotic elements that their skies turn alien, their weather transforming into weapons. These planets are not exceptions. They are proof that the cosmos does not favor balance. It favors diversity, so in every brutal, beautiful, and bizarre form it can create. And yet, hidden within that diversity, there are lessons for us. Strangest 2b, the darkest planet, reminds us that light itself can be swallowed, that not every world is meant to be seen. TOI 849b, the stripped giant, reminds us that even the largest can fall, that strength does not mean survival. 55 Cancri E, the diamond inferno, shows us that wealth without peace is meaningless, that beauty and horror can exist in the same place. WASP 12b, slowly devoured by its star, warns us that orbits are fragile, that proximity can be fatal, and that even planets have lifespans. HD 1997333b, the glass rain world, reminds us that even the familiar can be twisted, rain, clouds, and storms remade into weapons. Kepler 10b, the lava ocean, is a mirror of Earth's own fragility, showing what our world could have been had it formed just a little closer to the sun. When we look at these planets, we are not just cataloguing curiosities, we are looking into mirrors of possibility. They show us how worlds can live, how they can die, how they can be destroyed, and how they can endure. They show us that the Earth we stand on is not guaranteed, that life itself is a miracle, balanced on the edge of physics. They remind us that in a universe of molten seas, glass storms, diamond flames, and endless shadows, our blue and green world is the rarest jewel of all. And still, there is wonder in the horror. For even in the darkest planets, there is mystery. Scientists are not frightened by Strangest 2b's blackness. They are fascinated. They are not disheartened by WASP 12b's death. They are eager to watch and learn. Each strange world is a laboratory, a lesson, a story written in starlight. Every time we find one of these planets, we stretch our understanding of what the universe allows. Every one of them breaks the rules we once thought unbreakable. Perhaps the greatest secret these planets hold is this, that the universe is not built for us, it is not kind, it is not gentle, it is not designed to make us comfortable, it is designed only to exist, to push physics to its limits, to explore every possible shape of reality. If we want to survive in it, we must adapt, we must learn, we must understand. That is why we study these worlds, that is why we search, because each one, no matter how terrifying, brings us closer to understanding how rare, how fragile, and how precious life really is. And yet, for all their hostility, there is beauty in these dark worlds. Beauty in the ember glow of Strangest 2b, beauty in the broken skeleton of TOI 849b, beauty in the sparkling vision of a diamond world set aflame, beauty in a planet's tragic fall into its star, beauty in a storm of blue glass glittering in eternal lightning, beauty in a world glowing red with molten oceans. They are terrifying, yes, but they are also magnificent. They remind us that the universe is not just danger and death, but spectacle, a stage on which extremes play out, each one stranger than the last. As telescopes grow stronger, as missions like the James Webb Space Telescope peer deeper into the cosmos, we will find more of these worlds, stranger, harsher, deadlier planets than we can imagine today. And among them, perhaps we may also find others, planets where life might thrive, where oceans sparkle not with lava but with water, where skies are not weapons but shelters. But those will be rare. The lesson of these dark worlds is that life is the exception, death is the rule. So when you look up at the night sky, remember what hides among those stars. Not just distant Earths, but worlds of terror and silence. Places where rain cuts like knives, where diamonds burn in fire, where giants are stripped to their bones, where stars consume their children. These are the dark worlds and hidden secrets of the cosmos. They are the nightmares of creation, and yet they are real. And as you stand on Earth, breathing in the air, feeling the calm of oceans and winds that do not shred you apart, know this: in a universe of monsters, our world is a sanctuary. Fragile, yes. Temporary, yes. But beautiful beyond measure. The greatest secret these terrifying planets reveal is not about themselves, but about us. They tell us that against all odds, we live on one of the rarest and most miraculous worlds in existence. The universe is vast. It is cruel, it is strange, but it is also wondrous. And to journey through its dark worlds is to be reminded not only of what is out there, but of how lucky we are to be here.